For number 5 of 2016, this was a quiz, so please make sure you do it before you move on. Let's get started with this. It says the inside of a funnel of height 10 inches has circular cross sections as shown in the figure above or to the right. So here we have one circular cross section that you can see here. Okay. At height h, the radius of the funnel is given by this expression. Now, so as h increases, as we move h up, obviously the radius is going to get bigger, and so we have an equation that relates the radius to the height of the funnel. And then it says the units r and h are in inches. For part A, it says find the average value of the radius of the funnel. This is a pretty straightforward problem. I'm looking for the average value of the radius. So that would be 1 over 10 minus 0 times the integral from 0 to 10 of my radius for my integrand. So I just typed in that radius there. Now, so basically what it's saying is if we figure out this average value, this average radius, that would be equivalent to a cylinder. The volume of this guy would be equivalent to the cylinder with that average radius. Besides that, it didn't ask for that, so we're just going to solve this. Now this is a non-calculated problem, so it's going to require a lot of work to solve this because we have to take the antiderivative and everything. So the first thing I note is 1 over 20 is a constant, so I'm going to take that out. And then 1 over 10 minus 0 is 1 over 10, so I'll multiply those together. So I get 1 over 200 times the integral from 0 to 10 of 3 plus h squared. And then from here we have to take the antiderivative. So the antiderivative of 3 is 3h. The antiderivative of h squared is going to be 1/3 h cubed. And then we're going to evaluate from 0 to 10. So we plug in 10 to our h's, and we plug in 0 to our h's, and then we subtract those. Notice I put the 1 over 200 outside brackets because we are multiplying our results of our integral by that. Then I'm going to go ahead and simplify that. 3 times 10 is 30. 10 cubed divided by 3 is, we're just going to say 1,000 over 3. And then the rest of that zeroes out. That all cancels out. And then to simplify this further, we're going to get a common denominator here. So that's going to be 90 over 3. So that's 1,090 over 3. And then multiply that by 1 over 200. And then we end up simplifying all of that to 109 over 60. So our point values here, you're going to get 1 point for having the correct integral. So as long as you had the integral from 0 to 20 of 1 over 20 times 3 plus h squared dh, you got that 1 point. You're going to get 1 point for taking the antiderivative correctly. So whether you took the constant out and then took the antiderivative, or distributed and then took the antiderivative or something along that nature, you would have gotten 1 point for that correct antiderivative, and then 1 point for your final answer. I do want to note here, there's a lot of arithmetic going on here, so you should not be simplifying all of this. Once you get to this point, you do have to plug in 10 and 0, because this isn't just an expression, a numeric expression. We have to plug in the 10 and 0, so once we get to this point, you should stop. You should leave it here as a final answer, and you would get the points for the answer point. You would get the points for the answer point instead of worrying about whether you simplified it correctly or not. All right, for part B, it says find the volume of the funnel. So this is an application of our revolutions, finding the volume as we rotate or revolve around an axis. It just looks a little bit different here. So remember, to find the volume of anything in calculus, it's the volume of the area expression, the volume of the area equation. Well, in this case, because our cross section is a circle, we need the area of a circle here. So the area of a circle is pi times r squared. Pi times r squared. Well, here it is. Pi times, and it gave us the radius. The radius was given by this equation, so the radius squared, pi r squared. And then the integral is from 0 to 10 because we're looking for all the way the volume of the entire funnel. Now notice it's slicing it into an infinite set of cylinders. You can see that here. Here's pi r squared and then the height of each cylinder. And then we're summing it all up. Now, it says find the volume, so again, this is going to be a long process because it's not a calculator-based problem. I'm going to go ahead and take the 1 over 20 out because it's a constant, and notice, actually I can't take the 1 over 20 out because I'm squaring it. But I can take it out if I square it. Because I'm multiplying this, I can square the 1 over 20 and then square the 3 plus h squared separately. And so when I square 1 over 20, I get 1 over 400. And so I take that out and I get pi over 400 here. And then the 3 plus h squared is the other part of that. Now, remember, we can't just square both of these because there's a sum inside of it. So you can't say 3 squared and then h squared squared. You can't do that. But what you would do is maybe distribute all of that out. So if I multiply 3 plus h squared times 3 plus h squared, I'm going to end up with 9 plus 6h squared plus h to the fourth. And then go ahead and take the antiderivative of that guy. I couldn't take the antiderivative directly from here because I have a squared inside. If you tried u substitution, it wouldn't work. So that's why I had to expand it out. But from here, taking the antiderivative, you get 9h plus plus 2h cubed plus 1/5 h to the fifth. And then we're going to go ahead and plug in the 10 and the 0 and then subtract from there. And notice the constant that is being multiplied all outside those brackets. The second term here all cancels out, so that's kind of nice. And then we can simplify the first term to be 90 plus 2,000 plus 20,000, which simplifies to 20,090 over 400 pi, which again simplifies to 2,209 over 40 pi. As far as points go, and the units on that would be inches cubed if it asked. It didn't, so you don't have to worry about that. You get 1 point for having the correct integrand, so 1 point for this guy right here, the 1 over 20 times 3 plus h squared all squared. You're going to get 1 point for your correct antiderivative. So 1 point for this statement all together there. And then you're going to get 1 point for your answer. Again, a lot of arithmetic to get to your final answer. So once you're down to this line right here, this one, where you plugged in 10 and 0 and then put subtract, leave it there. That is your final answer and you get full points for that. Alright, as far as part C, it says the funnel contains liquid that is draining from the bottom. Drip, drip, drip. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. Wow. At this instant, what is the rate of change of the height of the liquid with respect to time? So I notice here that it's asking for the rate of change of the height with respect to time. So what we're looking for here is dh dt, or another way to say that is we're looking for h prime of t. That tells us that our variable that we're working with is t. We're taking our derivatives in respect to time, so keep that in mind. What we know here, based on what's given, it says at the moment when h equals 3, so I'm going to write that down, when h equals 3, the radius of the surface is decreasing at a rate of 1/5. So the radius is decreasing at a rate. Well, that means our dr dt, or r prime, is going to be negative because it's decreasing, because r is decreasing. So it's going to be negative 1/5. So we'd say dr dt is negative 1/5, or you could just say r prime is equal to negative 1/5. Okay? And then we are looking for dh dt. The only equation I have with h in it is this expression where it says r equals something about h, and that's a good thing because we have dr dt over here. So when I go to take this derivative, because I need h prime out of it, I'm going to take it in respect to time. So the derivative of r is dr dt, or r prime of t, and then the derivative of this side, the 3 plus h squared, well, or sorry, the 1 over 20 times that, I could distribute that in. So I'd get 3 over 20 plus 1 over 20 h squared. Then take the derivative, we'd end up with 1 over 10 times h, or just keeping the 1 over 20 constant out, and then the derivative of h squared is 2h. But then because we're taking the derivative in respect to time, h is a function, so it's going to be times dh dt. So that's my equation. I can simplify that just a little bit by getting rid of the 2 on top and the 20 on the bottom, reducing that to 1 over 10. Now, I am looking for in this equation, I'm looking for dH dt, so I got to figure out what this is. In other words, I need to know what dr dt is and what h is. And I have those two values here. Those were given, so I'm just going to plug those in here. So it's going to say negative 1/5 equals 3 over 10 times dH dt, and then solving for dH dt, you get negative 2/3. And so some people might say, couldn't I just leave the answer here? I mean, that's simplified. No, because it was asking for the actual value of this, so we have to isolate it in this case. But anyways, if we're going to put this into words, we would say the rate at which the height is changing is negative 2/3 inches per second. Or we could say the height is decreasing, because of the negative, the height is decreasing at a rate of 2/3 inches per second. So I put that into a sentence, but you could have also said the answer is just negative 2/3, and it didn't even say indicate units of measure. So you could have just said the answer is negative 2/3 when you're all said and done. You're going to get 2 points for the chain rule here. So knowing that you had to take the derivative in respect to time. So if you got to this point, you got 2 points, and then you're going to get 1 point for your final answer. All right, that's part C. That wraps up 2016 number 5. Make sure you grade it accurately and honestly, and then input your scores for the last 2 problems into Socrative. The next problem that we're going to do is a you-do problem. It's going to be question number 2 from 2015. It is a calculator-based problem. So do it to the best of your ability. Set a timer for 10 minutes and see how you did by grading it in the next video.